Hi grade 10. So this is the last of our topics for trigonometry, and there are 3D trig problems. What we're doing here is we're taking a situational problem, and essentially I want to try to create as many diagrams as possible. So this is about multiple diagrams. The reason that these are sometimes just a little bit longer to do is, again, trying to decipher that information. So we're going to go over how to decode and really how to organize our work so we can stay on track while solving these types of problems. The first thing I always want to do, and I'll highlight it here in orange, is I always want to make sure I make multiple diagrams. Okay, so several different ones, as many as possible. Generally, it's 3. The first perspective I usually focus on is a bird's eye view. A bird's eye view means view from above. So the view from above could be a base of a triangle, depending on the different situations. The second perspective is probably the left or the right side. And then the third could possibly be a front. So sometimes I need 2 different views, sometimes I need 3 different views. It just depends on the situation. We're going to go through 2 different types of problems just to focus setting these up. So here's our first example. Find the apex angle of the front face in the following diagram. Well, this is a little bit of a new word. Apex angle means the angle at the vertex. So the vertex angle. And in this situation, it's referring to the upper vertex, vertex A. So the question is saying, in that front face, if I go from A to B to C, in that dark blue triangle, I want to say, what is angle A? That's the final thing that I want to solve for. In order to start this, if I were to look at my overall goal, and that's what I like, so I'm just going to draw the front face of that diagram out, A, B, C. You'll notice that I don't actually have any measurements. That's the angle that I want to solve for, but I don't have any actual side lengths. The only sides I have in the question would be the back side of this 3-dimensional triangle, as well as this right-hand side. So notice here, this would be the back piece of the triangle. I have information about actually while I'm drawing that out, let's just draw that here. So copying these angles out. I have a height of 12, a length of 35, and remember this is A to C. Okay, so notice I have the base of these 2 triangles, and it tells me that there's a 90-degree triangle here. Perfect. What else do I see from the diagram? I see I have this triangle in the back here. So this is the left-hand side of the triangle. I'm just going to reshade that because I don't like the way that it looks. There we go. Looks better on that diagonal. So if I were to look from, again, this direction, I have a 90-degree angle in the corner. This is a 5 centimeter length. This is a 12. And remember, my overall hypotenuse is length AB. It's that shared side length here between the back triangle as well as the front face. The last bit of information I have is the bottom side of the triangle. The bottom side is my length BC. So I'm going to maybe highlight that bottom here in yellow. Okay. And this would be that yellow component here. So the bottom triangle is A, the base of A. Usually how we denote base is with A prime. So I'll write base of A. This is B and that is C. Notice this is the shared side length of the front face of that triangle. I label all the information I have, 35, 5, and I have 110. The reason this is important is because remember, the green diagram, this is my goal, is to solve this triangle. In order to solve for angle A, I need to have some side lengths for either length AB, BC, or AC. So I can use my triangles below. If I go from left to right, I can solve for length AB in this diagram, in the blue diagram, by using SOHCAHTOA. Remember, I have, relative to this diagram, I have my length of AB, and I can use Pythag. A squared plus B squared equals C squared. So 5 squared plus 12 gives me 13 when I square root. So the length of AB will be 13 units. So this is a solved length. I'm going to do all of my solved lengths in pink so you can see on the diagram that they have been solved. AB is 13. I might as well take that same information and translate it to my goal diagram to solve. Once I have AB, I can move, and just because Pythag is a little bit easier, I'm going to go all the way to the right-hand side and solve this diagram. I have AC squared is 12 squared plus 35 squared. And when I square root to solve for the length of AC, I get 37. Just as I stated before, I can fill that 37 in, AC, and remember that this is this length 37 here. I still can't solve for angle A. I need one more bit of information. I need that bottom length BC. So I'm going to turn to my center diagram to solve. Notice these are all tricks and techniques we've seen before. We just haven't really put them all together in these multiple ways. So now looking at the base of this diagram, I have two adjacent side lengths, 5 and 35, with a contained angle, so I can use cosine law to solve. I'll write my general cosine law out first. A squared is B squared plus C squared minus 2BC times the cos of angle A. From this diagram, the length I'm solving for is BC. So BC squared, this is 5 squared, 35 squared, 2, 5, 35 times the cosine of 110 degrees. What I'd like right now is I'd like for you to pause this video, and I want you to start going through the steps of solving for the angle, solving for length BC. So just checking your calculator to make sure I do all of the proper steps. Remember, when I solve for BC, don't forget to square root that entire value above. I should be left with a length of 37. So again, please practice that on your calculator and make sure you can get the same value as me. Filling that information in, 37 on the bottom, and lucky for me, 37. Now it's just a coincidence that the two side lengths, AC and BC, are the same length. I still want to go ahead and solve for that final value. Remember, my goal is to solve for angle A. This is a cosine law question. I have 3 side lengths and an unknown angle. Okay. To solve for angle A, we have A squared plus B squared. A squared equals B squared plus C squared. BC, cos of angle A. Now I have my side lengths. B has a side length of 5. It's 2 times 5 times 37 times the cos of angle A. Remember, to go through and solve, I really want to make sure that I am subtracting my two values. This becomes 37 squared minus 37 squared, so that's fine. Okay. Oh, I apologize. I'm just looking back to my diagram, and I copied B. B should be 13, not 5. The reason it should be 13, remember, I'm looking at this final triangle here. 13, 37, 37. So that's my fault. When I go through and rearrange, I'm going to get my cosine of my A and my A value to be 80 degrees. Please here, I want you to be able to check or validate with a friend. So at this point, try in your calculator to go through those values, solving for the cosine of A, and please be careful to watch your BEDMAS, your order of operations. Because remember, this is the term that I'm solving for. And that's it in this question. Therefore, angle A on the front face is 80 degrees. Question solved. So you can see I'm still using SOHCAHTOA, sine law, or cosine law in this case, to solve my triangle. So how many triangles can we create so that we can make a meaningful diagram? We've now solved a problem given a diagram, and in our second situation, we're going to solve a problem without a diagram. This one takes a little bit more notation, only because I have to create the diagram myself. So here's the information as we go. From point A, the summit of two mountains, B and C. I'm really only going that far. So I have one point in space, and I'm talking about the top of two other mountains, B and C. So for me, I'm picturing here's my point A, and in the distance I have 2 points, B and C. Now notice that these 2 points represent the summit or the top of the mountains. So this is going to be my aerial view, or my view from above. Like, think of airplane view. So kind of if you want to envision that there are, well, that doesn't look like a mountain, that looks like a Christmas tree, but that there are mountain ranges below those values. Okay, so this is from the top of that. If I were to look here, it tells me a little bit of information. It says that these two mountains, B and C, are on a bearing of 24 and 58 degrees from point A. So that means from point A to B, if it's on a bearing of 24, that's relative to true north. It means this angle is 24 degrees. Right? Straight ahead would be 0 and 24 to the right. If I were to look at that angle between A and C, it doesn't quite line up, but that's fine. Actually, that's going to bother me, so I'll redraw it. If I look at this angle, it says that whole angle is 58 degrees. Okay, I'll do that in green. From start to finish, that's not what I meant to do. I'll maybe do it on the outside. That angle, 58 degrees. I want to be really careful, and I'm actually going to take that and just draw it outside, because I want to see if I can include an inside angle, and I should be able to. Given my diagram, I have this information available. My inside angle becomes 90 degrees minus my 24. That should give me the remaining angle on the inside. So I have a remaining angle of 34 degrees. So on the inside of my triangle, 34. And then I also have BC connecting. Okay, so this is the top of those mountain ranges. Again, I'll just remove it, but envision that this is what the bird would see. So aerial view, I have 3 side lengths and 1 interior angle of 34 degrees. So that's the important information there. Let's keep going with the question. It also tells me that C is due east of B. Okay, for me, this would have been better stated at the beginning of the question because it's a directionality. It says to go from C to C to B, I've gone east. Due east, think of from one point I'm going totally east. Well, that makes that angle a 90 degree. So the angle between C and B is a 90 degree angle. So relative to north, this is a 90. Although it doesn't look like a 90, it really is. That's okay. So just recalling that that's a 90 degree angle. There's one other thing I look for. If I'm looking for the overall Z rule, to solve for that whole angle B, notice I'm just drawing it here in purple. These lines are parallel, right? True north, which means that this angle, 24, would be the same as this side angle here. Just taking that away, this inside angle is 24 degrees. I really encourage you to redraw a final aerial diagram. Angle A, we said was 34 degrees. Angle C I don't know, but I do know B. Remember, my inside angle in total would be 90 plus 24 degrees. So I have 114 degrees on the inside of my triangle. Perfect, that's my aerial view. Continuing on with the question, what other information can I have? Well, it tells me that the angle of elevation, remember that's the angle from the ground to the top of something, is 8.5 and 9.3 respectively. That means from point A. So if I were to look at my side views, from point A on the ground looking all the way up, all the way up to the top. Remember in the diagram above, B represented my summit, the top of the mountain. Top. I can call that point below anything, but I will use B prime for below. It really doesn't matter. I could have called it anything. Again, to reiterate, this is the top of my mountain. Those would be the snow caps of B. So that's that mountain right below. The angle of elevation is 8.5 degrees. And remember that my mountain, when cut in half like this, is a 90-degree angle. The other side view of my mountain that I would have would be from A to the top of C. I'll call my bottom C prime. Again, it's really up to you. That's the top of the mountain for C, and my angle of elevation is 9.3 degrees. Again, I have a 90-degree triangle. The only other piece of information I have is it tells me that my B, the top of my summit, is 850 meters above point A. So this is my 850 meters. So part A is asking, what is the horizontal distance from B to A to the nearest meter? I look and see what diagram is helpful. Well, horizontal distance, that's the x distance between A and B. So this side view diagram would be the most beneficial. So when solving question A, I'm solving for that length here. I have a 90-degree triangle. I have an opposite but no adjacent. So I'm going to set up a tangent ratio. The tangent of 8.5 is opposite over adjacent. And let's call this length x. 850 over the tangent of 8.5. Again, I'm going through and solving, and I get my length of x to be 5,687. Perfect. That's the horizontal distance AB. Remember, there's a nice way that we can state this. The length of A to B is 5,687. And my units are, I believe, in meters? Yes. Meters. I can change that to kilometers if I wanted to. What does the second part say? Determine the height from C above A. So how far apart is this? Well, in order to solve for that, I would need more information. I would need, say, the length of A to C. I need something. If I look in my aerial view, remember, I have the lengths of my summits. I have all this information. From my aerial view, I can do a sine law. The reason being is I have the distance from A to B. So using that information, I can solve for these different side lengths. Right here. Solving for AB, I actually have that information here. So I can solve for length AB. The way I do this is by doing Pythag on my first side view. AB prime plus B prime B should give me the length AB. So 5687 squared plus 850 squared equals AB squared. And I'm going through and I'm solving them. So give yourself a second to see if you can calculate these values here. Again, I'm just going to pull out my calculator for these values. And I have 5687 squared plus 50 squared. And I want to square root that whole value. Okay. So I should get AB to be 5,750. Hey, yay, I have a side length. If I wanted to solve for my length BC, I can do that from diagram above. Remember, the only way I can solve for length AC would be to have one more side length. So from aerial view, I'm going to use sine law. Sine law will allow me to say the length of this angle of side length over that angle equals the length of this side length over that angle. Remember, I have that bit of information. I just solved for length AB, and because all my angles in a triangle must add up to 360, I also know this inside angle. I'll take those away. For angle C, 180 minus 114 minus 34 gives me an angle of 32 degrees. So let's set up a sine law. The length of 5750 over the sine of 32 should be equal to the length of, let's say, AC, that's the side I want to solve for, over the sine of 114. Okay, so I actually just switched the side length I was solving for. The reason being, it gives me a faster way to solve my problem. So I'm doing those two opposites. Remember, my goal is to get a side length in this diagram right now. Okay, so using my calculator and going through those steps, I want to have sine of 115 multiplied by 114.1 multiplied by 5750, all divided by the sine of 32. Okay. Remembering that gives me length of AC 8185.4. I'll fill that information into my diagram. 8185.4. Now, I can do my final step in this question. Remember, it was a long one. It wanted to know what was the vertical height from C to C. So in that situation, I now have a hypotenuse and I want to solve for opposite. So the sine of 9.3 degrees equals opposite. Let's call that y over hypotenuse. And if I solve for this, again, just taking my calculator, 8185.4 times by the sine of 9.3, I should get just over 1,000, 1,018.7. And I'm finally done with the question. Therefore, C is, I think it asked to the nearest unit, nearest meter, 19 meters above A. So these types of problems always, excuse me, apologize. These types of problems always follow the same methods. Create as many diagrams as possible, and the key to being successful is to be very clear in your diagrams what I am solving for. That's why I go through the process of highlighting my different solve for lines, so it kind of keeps me in check. Working through the questions in the textbook, I really encourage you to do this in pairs. This is not something you want to do alone, because it's nice to talk it through and compare diagrams. All right, thank you guys.